All right, so I think this is recording. Let's take a look at this problem. We are looking at identities, but also we can use our previous knowledge. If I were doing this without trying to use identities, angle C, I'm not interested in information about angles A and B. I don't even know if they're in the same triangle. If I draw a right triangle for angle C, if the tangent of angle C is 5 over 2, then opposite leg over the adjacent leg, then this triangle is definitely going to be similar to the whatever original triangle they had. And a squared plus b squared, 25 plus 4 is 29, and the square root of 29 using the Pythagorean theorem. Um, so the cosine is the adjacent side over the hypotenuse. 2 over radical 29, rationalize the denominator, and we have our answer that the cosine of angle C is 2 times radical 29 divided by 29. Nothing cancels there, so that's my answer using just a right triangle constructed from the two of the three sides given, and the fact that I can use similar triangles. So let's see if we can do the same thing maybe with one of the recent trig identities that we've used, that we've learned. Um, I don't have an identity that really. I've got the quotient identity, which the tangent is the sine of C over the cosine of C, and so I suppose I could look back and see in one of the previous, have I found the sine of C yet? And I don't think I did. Okay, yeah, but we haven't done that. So what we could do here is we know that cosine and secant are reciprocals of each other, and I know that the secant squared of angle C is going to be the same thing as 1 plus the tangent squared of angle C from my Pythagorean identities. Um, so if I solve this for secant of C, I can't talk. Um, if angles A, B, and C are in the first quadrant, I don't have to worry about a plus or minus symbol there. If they've given me that tangent of angle C is 5 over 2, I have 1 plus 5 over 2 squared, and or did I already do secant of C? Oh, I did secant of C already. Two different ways. I'm like, man, this is looking pretty familiar. So if I jump, then you can look well, let's just keep going. I guess I'm already all the way done. I was like, man, this is looking familiar. Um, so if I add these two together, I've got 25 plus 4, which is 29. I've got the secant of C is radical 29 over 2. But now I'm going to take the reciprocal of that. I know that the cosine of angle C is 1 over the secant of angle C. So if I take 1 over the square root of 29 over 2, that's saying to flip it. That's saying to take the inverse. So that's 2 over radical 29, which rationalizes to 2 radical 29 over 29, which is the same answer we had as before. So I redid secant C and then recognized, oh, I just did it. So sorry about that. It is. You sometimes do that. You do have to be aware that if you've done work in a previous problem, then you're free to use that. I mean, you didn't do that for nothing. So use your previous work and your previous knowledge when doing these. So hey, I hope that helps, and I'll talk to you later. And maybe this will be the last one of the evening since I'm getting a little bit tired. So hey, I'll talk to you later.